Chapter 3 Simulation. What is the next big thing in tech? This is a question that all of the big tech companies are asking themselves, and it's a question, it's a challenge that all the big tech companies are trying to solve. You remember these guys, right? 7 of the world's 10 most valuable companies are tech companies, and they are all engaged in a furious race to figure out who is going to become the next major technology platform, who is going to create the next killer technological device. You see, technology tends to evolve in cycles. So roughly once every 13 years, we see the emergence of a new technology device or a new computing platform that really upends everything that came before. So in the early 1980s, we saw the advent of the personal computer. Then we had the arrival of the internet. Then in the mid-2000s, the arrival of the mobile phone. And each of those were revolutions in their own right. What that means is that we're now just about on time for the next revolution. And so all the big tech companies are trying to see who's going to get there first. Microsoft won the battle of the personal computer. Companies like Google and Amazon won the arrival of the internet. And we had Google and companies like Facebook and Apple winning the mobile phone. So all of these companies understand that there is a massive prize here up for grabs. So what is the next major computing platform? What is the next big device in technology likely to be? Well, thanks to the smartphone wars of the last decade, the cameras and the sensors and the chips in our phones are now super cheap. Inside your phone, there are an array of incredible sensors, not just touchscreens and microphones, but things like proximity sensors, ambient light sensors, pedometers, barometers, thermometers, GPS, things that allow your phone to track where you are, to interact with the world around it. And all of those little pieces of technology have become super cheap thanks to economies of scale and through the sheer act of learning by doing. So when you put those cameras and those sensors and those chips into other kinds of devices, you start getting new kinds of capabilities. This is something that Google tried to do back in 2013. They created a headset that allowed users to take films and videos of the world around them and also had an overlay. But the problem is that it was a horrible failure, because Google failed to take heed of that lesson that we learned in Chapter 1, which is that disruption happens as a result of ecosystems rather than because of individual products or companies. And also that customers care more about the experience that the product gives them rather than the technology or the product itself. Google, it turns out, had built this product, but there was no ecosystem in place to support it from other companies or from the tech industry, and that customers weren't necessarily looking for the experience that it afforded them. More recently, we've seen the rise of wearables, and that has been something that has been more successful. Watches, rings, Fitbits, heart rate monitors. Apple Watch now outsells on its own the entire Swiss watch industry. Wearables, it's actually going to be devices that we strap on and look inside, devices that allow us to interact with both virtual and digital worlds and allow us to overlay those virtual and digital worlds onto the real world around us. This really burst onto the public's consciousness with the arrival of augmented reality a few years ago. And it was thanks to this game. It was something called Pokemon Go, which allowed users to walk around the world around them and collect these little virtual characters called Pokemons, and you'd get points for collecting certain Pokemons, and then you could compete against other people. Now, to us, that might look silly, but Pokemon Go has been played and tried by tens, hundreds of millions of people. And that's really interesting because a lot of technologies often start out as games or as toys and then eventually find their ways into commercial use. Already, about 1 billion people have tried augmented reality at least once, and around 300 million are regular users, according to a report from Deloitte in 2019. And with augmented reality, you can do everything from checking out what a tattoo might look like through to looking at products in your living room. That's what IKEA has done with their new product range. And so IKEA now allows you to take a product and look at on their catalog, and then you can, on your phone, highlight your living room and you can have a look and see what that furniture might look like. And so you can move it around. This makes the shopping experience in IKEA a lot more engaging, and it means that people can quite literally try. IKEA, it turns out, aren't alone. Whether you need to augment 3D online shopping with 3D products, or you can have field agents like showing their customers what their buying looks like. You can augment the in-store experience. You can bring objects into your factory floor or into your office to see what they look like. This is a total revolution in customer experience, and as this technology gets better, it's going to start arriving on millions of phones around the world. And of course, if you can have a look at a product before you buy it, why not have a look at your entire house, which is what another company from Australia, Real AR, has done. Just by using the floor plans of a house, they're able to show the customer what that house might look like as a new build.
So using any flat surface with a smartphone or tablet, and see your new build as a model or a floor plan. It's incredible. So even before the house is built, you can walk through plans. So not only can you walk through life size, but also you can put this in any open space, which is actually incredible because that now means you can put your plans on the actual site that you want to build. And this is where the real magic happens. We've specifically designed Realr so that real estate agents and home builders can work with buyers to save them time and money with expensive changes.
Think about the kinds of applications that technology has, for example, in the construction industry, in mining, in heavy industries, where you can use the virtual design before you actually start building. So that's augmented reality, which is the projection of digital objects onto the real world via a screen in front of you. Then you've got virtual reality, which is when you strap on a headset and you immerse yourself entirely inside the virtual world. And once again, the price of virtual reality headsets has come down significantly in the last few years, and their performance has increased drastically. This is the Oculus Quest. This is currently the sort of gold standard virtual reality headset. It came out in spring last year, and it costs around $400 US. And the resolution now allows you, for example, to have a look and see what your new house might look like before you go in. This is something that real estate agents are using right now. And that virtual environment can be entered come rain or shine. Look at the level of detail that you're now able to achieve using these virtual environments. And it means that once again, people can walk through, for example, a
One of the things that really helped us during the construction verification scanning was that we were able to find some of the issues in very early stages, so we could address it much easier and with less cost. Sometimes if you miss something in the construction phase, it is much harder and much costlier to address it when the construction is progressing. So I can tell you we definitely found some issues that just through virtual walkthroughs and doing measurements and verifying the scans versus the drawings, we found some issues that we immediately addressed and definitely saved us time and money in the long run.
Remember as well that these technologies, the ability to both 3D scan and then put your customer in a virtual reality headset and allow them to step through the floor plans, these technologies are now available to everyone. This is the Rika Theta V. It's a 3D camera that starts at around $400, and you can buy a 3D camera like this and walk through any construction site, allowing your customer or your clients to step through it. And the other place that virtual reality is turning out to be incredibly useful is in training. Walmart now has over 10,000 virtual reality headsets, and it conducts all of its training for staff in virtual reality.
The thought of it is pretty cool, but how are you to train me with VR?
Like, it was just a crazy idea, but after seeing it, it has actually helped me train a lot better.
Pretty much every class implement some type of VR training. You might want to show our associates how to deal with a deli fire or how to run Black Friday. Is really important to be able to show them, but it's virtually impossible to recreate that scene.
Going through the VR and actually feeling like I'm physically in it and making those decisions. So it makes me feel very comfortable being able to go straight to the sales floor because I've already done it.
In the United Kingdom, emergency services are using this technology to train first responders. It allows them to step people through what they should be doing when they arrive on the scene. And it means that the instructors can walk them through step by step without needing to use real people or live dummies. This turns out to be a far more effective way to train people as first responders. And it means that they can go in detail through exactly what the trainee has done and then replay it to show them areas where they could improve. What's also powerful about this newer breed of virtual reality devices is that we have access now to haptic feedback, so devices that allow you to immerse your body into that virtual environment. Controllers that allow you to, for example, move around your hands. What these haptic feedback devices do is they make the experience feel more visceral and allows you to immerse yourself more fully in the experience. And it opens up the possibility for training, not just for retail or for emergency services, but also for healthcare and doctors and to medicine itself. This is a haptic feedback device that operates as a surgical scalpel or as a pen. So that's connected to the virtual reality headset, and it allows the trainee to wield a tool. And because it's in a virtual environment, the software in the program can turn that tool into whatever it wants.
My name is Brodnik Boschek. I'm a full-time spinal surgeon trained in orthopedic and neurosurgical spinal procedures. My main focus is on complex reconstructive procedures of the entire spine involving tumors and deformity. And in this field, I'm very much aware of the technical complexities and the long working hours and many years it requires to train to become proficient in these different techniques. Training on the job with these kind of techniques is pretty much like going into being a musician and going and learning to play your instrument during a concert. When looking at complex reconstructive spinal procedure, the cornerstone really is the pedicle screw, so how to insert the implants into the spine with what Fundamental can offer. We can recreate the specific tactile feel of passing through the pedicle, the angles, we can create those so that the muscle memory and all these subconscious learning effect is there. The same as a musician learns chords and scales, and after a time this becomes intuitive and you no longer need to think about what you're doing. This is the last thing people learn because it's the most difficult and it's one spent least time on, yet it's the one which has the greatest hazards. And it's exciting new developments like the fundamental VR simulations, which now actually allow us to develop tools for this kind of training to fill this gap.
Do you remember how your phone improved very quickly over a number of years? How the camera got better and the megapixels went up, the bandwidth, the speed improved, the operating system improved as well? Well, that's what's happening with virtual reality. And what's particularly exciting is our ability to use cameras to take what's in the real world and then create a digital version of that inside a virtual space. This is particularly true for avatars or representations of people. And when Facebook first tried doing this, they came up with this concept known as toy heads. This was back in 2014, and as you can see, that's not going to be very easy to sell to anybody. I don't think anyone can get excited about these things in a virtual environment. Fast forward to today, and we now have entire lighting rigs that capture in high resolution, in incredible detail, every aspect of a person's face, and are then able to recreate that in VR. Here's what virtual reality avatars look like in 2020.
What do you do for exercise?
I do yoga and then I do boxing too.
What kind of yoga? Wait, okay, yoga and boxing.
Yeah, there's a nice contrast.
Yeah, okay.
Yeah.
What kind of yoga do you do?
You ready? Because now it's going to start getting really weird. What happens if we can then take the virtual representation of a person that is being captured in high fidelity and then project it not inside a virtual reality headset, but actually project it back out into the real world? Well, then you get holograms.
With the whole of glamorous LA to choose from, they put me in a box, in a warehouse. Although it is the coolest box I've been in for a while, because, spoiler alert, I'm not really in the box. I'm out here. And that's virtual me. And it's called Portal.
Hey everybody, David Nussbaum with Portal. Portal is a hologram entertainment and production company. We stage hologram projections all over the world inside of this machine. What you're looking at right now is a 7 foot tall, 4.5 foot wide, 2.5 foot deep hollow
Now, I see a lot of stuff in this line of research, but that one, that one really blows my mind. Okay, so what happens when we bring kind of all these technologies together? You get something known as mixed reality. And mixed reality is really a kind of seamless blend between the virtual and the real worlds. In augmented reality, you have a digital overlay that is put onto the real world, but the two of them don't really interact. And in virtual reality, you are fully immersed within the virtual world. It doesn't really have kind of any bearing and interaction with the outside world around it. In mixed reality, however, that digital projection that is put into the real world can actually interact with the real world. It can see surfaces, it can move around, and this is what's known as mixed reality. And so we're starting to see these kinds of devices by a number of the tech companies. What you're looking at over here is the HoloLens by Microsoft. And the first place we're going to see these devices isn't in the office, it's not going to be on the gamers, because the tech companies understand that there's a huge part of the workforce globally that doesn't have desks. These are the people on the factory floors, on construction sites, and out in the fields. In fact, 80% of the global workforce are what are called frontline workers, and they number around 2 billion people worldwide.
We've been looking at the critical workflows for the first-line worker, and we are committed to bringing products to market to help them do their jobs more effectively. One of the first critical workflows that we uncovered was for the field service worker who often needs to call in for some expert help. And with mixed reality, we can bring the expert to them, and the expert can see what they're seeing and can annotate into their space and help them solve the problem and verify that's been done correctly. Another critical workflow that we've uncovered is around training employees on new products, processes, equipment. Companies are spending a lot of time and money on this today, and these things change often, and they're so critical to their operations.
This stuff isn't just in nice marketing videos. These technologies are actually being used by industrial companies around the world. Porsche, for example, has been using augmented reality and mixed reality to put up engine schematics for their service resolution workers. And that's resulted in a 40% reduction in service resolution time.
Anywhere from 3 wires, 4 wires to 100 wires to go into one connector. So every little bit of technology really does help. Once you put them on, you'll say Skylight. It'll show you on the diagram, and then you'll take the wire and you'll just pop it in fast as heck.
You know, there's video streaming. If you have an issue, they can see it from their laptop or wherever because you're streaming it through your glasses. Then you can store it. Anytime you pull up that assembly, they could actually watch the video and say, okay, I need to build it like this. This is what the final product should look like.
Okay, Skylight, local search 186A.
When you combine all of these technologies together, the umbrella term for them is something known as XR, extended reality. It includes the entire spectrum from the complete real to the complete virtual. And this is what they're calling it now in industry. But I actually like to think of them as simulation technology. And for me, the most powerful application of simulation technologies is something known as the digital twin. This was a technology that was pioneered in the oil and gas industries by companies such as General Electric and by Siemens, where they are able to create a virtual replica of a real-world object, anything from a machine to an oil rig to a building, and then they're able to test out in real time different factors, stress loads. They're able to also monitor in real time things that are happening on the real world. And what I find really exciting here is not necessarily how amazing the technology itself is, it's the value that it brings to customers' digital industrial transformation. Customers of Siemens have increased their reliability. People have been using this from 93% to 99% in less than 2 years. They've been able to reduce reactive maintenance by 40%. One company was able to save $360,000 by predicting a power outage in a gas plant. These are the kinds of results that meant that General Electric really went all in on these technologies. It was an early adopter, and today the company now has 1.2 million digital twins of its physical assets. That's up from 660,000 at the end of 2016. The beauty of a digital twin is that you can simulate just about everything, anything from factory floor to an engine. That's why Rolls-Royce has decided to embrace this technology. They're pioneering something known as the intelligent engine, which is an engine that's connected with the other engines that it's operating with. It's also connected with its support system, with its airline, and that allows it to sense and respond to changes in the operating environment. The engine is contextually aware. It means that it's aware of its current operating context and the requirements of the airline that it's operating within. Advice to minimize fuel burn and operational risks, that's created by the engine itself. It's self-aware. It knows when it needs maintenance, and in the future may even be able to perform that maintenance itself without any human interaction. It learns. It learns from its experiences and those of other engines in the fleet, identifying and fixing issues long before they have any impact on the airline's operation. What they're finding is that with the advances in computing, the models that they're making are real virtual representations of the engines, and these are much better than just number crunching simple calculations, which they were forced to do in the past. They're now moving on to be able to actually visualize and use this data even more effectively. Previously, they didn't have access to that. In essence, from the digital twin, they can study and predict the physical behaviors that an engine would exhibit under very extreme conditions. They can replicate the very unlikely event of the engine losing one of its large fan blades at the front, for example, and then map out and the exact effect that this would have on the engine and its surroundings. Here in Australia, they've pioneered a digital twin of an entire city. That's what the city of Sydney has done, where they've created a virtual map, an interactive platform that captures and displays real-time 3D and 4D spatial data which models their urban environment. That facilitates better planning, design and modelling for the future needs in New South Wales, and it includes the integration of live transport feeds as well as infrastructure building models. So what that means is that infrastructure developers can use the digital twin to identify the location of underground utilities before building works commence, or they can see the potential impact of planned infrastructure. It's an aggregation in the virtual realm of high-value transport infrastructure, property planning and environmental data sets directly from the owners, governments and industry to ensure that everyone's working off the same data and then using that data to effectively respond to different build and natural environments. And you can even have a digital twin of the human body. This is a project that's been pioneered by Siemens, and what they're hoping to one day be able to create is that every single person has their own digital twin. In other words, somewhere on a computer server is a digital twin being monitored in real time by sensors on your own body, allowing them to pick up disease and to identify health issues before you even realize you have one. This is why Satya Nadella, the CEO of Microsoft, says that digital twins are one of the biggest trends in technology. Sophisticated digital representations of the real world are going to optimize information flows and catalyze economic growth. Bits will help atoms be more efficient by bridging offline and online. This is the real kicker, and it's the fundamental message that's at the core of this entire chapter, of this entire lesson, this lesson on simulation, which is that by bringing the digital world into the real world and allowing the two of them to interact in real time, we get productivity and efficiency gains that were previously unimaginable. We're going to speak more about that in the next chapter when we dive into artificial intelligence. Before we do that, though, one last reminder of where we all came from. All of these technologies, virtual reality, augmented reality, mixed reality, digital twins, they all originated in the gaming industry. The gaming industry was born in the 1970s and 1980s, and it's worth just reminding ourselves that this is how far the technology has come. These games are all from the early 1980s, so these games are about as old as I am. In the next piece of content, what I'd like you to do is I'd like you to now go watch a YouTube video. It's called a demo of the Unreal Engine, and I want you to see just how far gaming technology has come in the lifetime of a single person.